Good morning, dear student. Welcome to online DSS classes. Today our topic is we will deal about drift velocity. What is drift velocity? For that purpose, consider a conductor having n free electrons. When we have not connected it to any source of EMF, then all the electrons will move in random fashion. All the free electrons will acquire a velocity due to room temperature and they will move in random fashion. Suppose that this has thermal velocity u1, u2, u3, and similarly if nth electron pauses, then it has velocity un. They are moving in random fashion such that there will be no net flow of electron. What does this mean that they have no net flow of electron? It means that their average thermal velocity must be 0. What does this mean? 10 goes this side, then 10 goes this side, 10 upside, then 10 downside, so that there may be no net flow of electron in a particular direction. There must not be any flow of electron in a particular direction. But what happens when a potential difference is applied? Means now we are connecting it to a battery. When we will connect it to battery, I am showing only for one electron, equally applicable to all electrons. एक इलेक्ट्रॉन के लिए दिखा रहे हैं, वो सारे इलेक्ट्रॉन्स के लिए वैलिड है. So when a potential difference is applied, means this end is maintained at positive and this end is at negative. Then what happens? Then electron which have a random thermal velocity will suffer a force in a particular direction. Similarly, all the electrons which are having velocity in different direction, they will suffer a force in a particular direction. Why they will suffer a force? Because due to this potential difference, an electric field will be applied. And this electric field will apply a negative force opposite to itself. So now all the electrons begin to move in one particular direction under this electric field. But when it will happen? When we will apply a potential difference. Now what happened? Let us study for one electron equally applicable to other. Now, when a potential difference is applied, then all electron will experience a force in particular direction. As we have seen, that force will be given by E into E, where E is charge on electron. Why this negative sign? Because electric field is in this direction and force experienced by electron is in this direction. Both are opposite. That's why negative. But force is equal to mass into acceleration. So from here, if we will take out, then acceleration comes out to be. We equate both minus E by m. So electron will accelerate by this acceleration toward positive end of conductor. Toward this end of conductor. But what will happen? Let's see. Electron has velocity in this direction. It is experiencing force in this direction. So surely it will move on this path. Surely it will move on this path in the way it will suffer collision with immobile ions or atoms. Atom और ion से collision suffer करेगा, due to which its path changes. From here to here, it moves under this force, and yeah, it means accelerated motion. It will gain velocity, but on collision, it will lose. It will give its gained kinetic energy to this collision जिससे टकराया है, to that ions or atoms. Again, second collision, path change, path change, path change, finally reaching it. Means when electron will move, it will suffer multiple collision before reaching to positive end of conductor. It will suffer multiple collision. For example, in the figure we have shown 1, 2, 3, 4, 5. 5 collision we have seen. But in real it must be very large. We have just shown to understand it. So when electron moves from one end of conductor to another end, it suffers multiple collisions. Due to this, its average velocity get reduces. So the average velocity by which an electron moves from one end of conductor to another end is called as drift velocity. So what is drift velocity? The average velocity with which free electrons, या better to say charged particle, liquid है तो solid के केस में electron, charged particle moves from one end of conductor to another end of conductor is called as drift speed or drift velocity. ठीक? So, look one thing more. This is first collision and this is second collision. So, path between first collision to second collision is called as free path. Means if it is A and B, so AB will be called as free path. If we look, electron has multiple free path, 1, 2, 3, 4, multiple 1, 2, 3, 4, 5, multiple free path. So the mean of all these free path is called as mean free path. ठीक? Time taken, ए भी ट्रेवल करने में टाइम लगेगा ना, पहली कोलिजन दूसरी कोलिजन टू सक्सेसिव कोलिजन, इसको रिप्रेजेंट करते हैं, वी रिप्रेजेंट इट बाय टाउ एंड वी कॉल्ड इट एज रिलैक्सेशन टाइम. वी कॉल इट एज रिलैक्सेशन टाइम. सो हाउ मच रिलैक्सेशन टाइम इट इज having? 1, 2, 3, 4, sorry, from here also, so 1, 2, 3, 4, 5 relaxation time. So all average of all the relaxation time is here, mean relaxation time or average relaxation time. Now when electron accelerate, so let's talk about this. So for first electron, if we talk about for first electron, so since V is equal to U plus AT as per equation of motion, therefore before colliding here, before suffering collision, means one collision, and after that before next collision, what will be its velocity? We are assuming V. Since it is first electron, so velocity is U1, we are assuming U1. Then initial U1, acceleration A, and time we called that was relaxation time. So it is having multiple relaxation time. So this is tau 1, means it is first relaxation time. For second electron, Let's deal about for second electron. Now we will look for second electron. What we will obtain? Let us consider if U1 then V1. This is the core formula which we are applying. Then V2 vector is equal to U2 plus A tau 2. Like this, things continues, means for first electron, for second electron, similarly for nth electron, what we will write? V nth is equal to U nth plus A tau nth. Sorry, this will be only because it is time. So this will be for first, second. If we write for third, what we will write? V3 is equal to U3 plus A tau 3. Similarly for n, the average of all these, this and this will give us drift velocity. So therefore, drift velocity is equal to average of all these velocity, because electron is drifting toward positive and with this velocity is only. So what will be drift velocity? V1, V2, V3 plus dot 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 Vn, and we will take average of this. Drift velocity is represented by Vd. So Vd is equal to, what is value of V1? U1 A tau 1 plus U2 A tau 2. We can put vector over acceleration plus dot 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 Un A tau 1 upon n. Now we are separating the quantities, means what we are doing, U1, U2, Un we are taking in one bracket plus A tau 1, A tau 2, similarly A tau 1 together. So we are taking common A. So what will be remaining? Tau 1, tau 2 plus dot 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 tau n upon n. Take. Now we are separating the denominator also. What means? Upon n and upon n. If we look, what is this? This is average thermal velocity. And what is this? Average relaxation time. That is average thermal velocity, and that is average relaxation time. So if we look, average thermal velocity was 0, and let us assume average thermal velocity as tau. So now what our expression converted to? Vd is equal to A tau. Now we will put the value of tau. What was value of value of A? What we have taken out? Minus E upon m. So now we will get the expression for drift velocity. And what will be value of drift velocity? We will get the value of drift velocity as Vd is equal to minus E tau upon This is the required expression for drift velocity, where tau is average relaxation time. So this is, we have taken out in vector form. This is the required expression for drift velocity and how the electron moves from one end to another end in a conductor. होप सो आपको समझ में आया हो, जहाँ नहीं आया होगा प्लीज़ पूछ लीजिएगा. थैंक यू.